Miss Healy here. Time for us to talk about Newton, the man, the legend, and his laws. So first, who is Newton? Newton was a brilliant scientist who focused on math and physics, born in 1642 off the eastern coast in England. The legend is that he figured out force and gravity because of an apple that fell on his head. Well, it turns out that that force that governed or controlled the moon was actually the same force that controlled that falling apple. Besides the fact that Newton is just a really awesome scientist, the thing that y'all really need to make sure you know is that he has 3 laws of motion, and these 3 laws have 2 different names. There's Newton's first law, which is the same thing as the law of inertia. There's his second law, which is the same thing as the law of force and acceleration. And then there's his third law, which is the same thing as the law of action-reaction. Now, I know that you really watch these videos twice like you're supposed to, once for notes and once to hear what I'm saying. But if you really do, then in your notes underneath this chart, I want you to draw this heart and then write I heart Newton. But on a more serious note, you really need to make sure that you know the laws by both the names, because sometimes on tests and quizzes we'll say based on his first law of motion, blah 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 blah, or sometimes we'll say based on the law of inertia. So make sure you know both the names for each of the 3 laws. Newton's first law states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted on by an unbalanced force. So here are 3 examples. The first example is you riding in a car. You're sad looking right now in this picture because you're about to hit something. So you hit, or you're about to stop. Let's say we'll stop instead. So you're about to stop. Your body keeps on going. And the only reason that it doesn't keep going all the way in through the windshield is because of the fact that you have this force right here, the seatbelt, that stops you. Otherwise, you would stay in motion. Take this ball here. You're happy, you kick this soccer ball. The soccer ball would keep going if nothing else was causing it to stop, if there was no unbalanced force. But since there's gravity and there's friction, the ball will eventually stop. Same thing with this marble. If there was no unbalanced force, this marble would go until eternity. But since friction and gravity act on this marble, it's eventually going to stop. Newton's second law states that force equals mass times acceleration. Let's explain it using this picture of the trains. If you don't want to draw the trains, that's okay, but make sure you get these statements. So we're going to compare mass and acceleration and force. So a large force, small mass, gives us a lot of acceleration. Small force, small mass, less acceleration. Large force, large mass, less acceleration. Small force, large mass gives us a small acceleration. Oh my goodness, how'd this get here? Looks like we have another magic triangle. It's the magic triangle of force. That's right, folks. We're going to be doing some calculations later. Just make sure you really understand how force, mass, and acceleration relate to each other using these trains. And don't worry, we'll do more stuff in class too. May the mass times acceleration be with you. Newton's third law of motion states that for every action, there's an equal and opposite reaction. This one gets pretty tricky sometimes, but right now we'll keep it easy. Think about if you're ever on a boat and you go to hop off the boat. It's very difficult to hop off the boat because while you're trying to go this way, that's your action, there's an equal and opposite reaction happening and the boat's going to go the other way. And if you're not careful, you're going to end up wet. Splash. Okay. Now let's look over here at the rocket. Same thing. Rocket's going to go up, but at the same time, it's forcing stuff down with air friction and the weight of the rocket. And we're going to do some cool stuff with rockets in class, so hang tight on that. Just know that there's 2 things. There's always an action and always a reaction. And it's evident here if you look at the guy who's pushing against the wall, but he's on a skateboard, so he pushes against the wall, but he ends up going away from the wall. Action, reaction. Here's your sources. Watch it again, take your notes, and happy trails, guys.